Welcome to Engineering Chemistry class, Unit 3, Lesson 2. Today we are going to see the construction and working of glass electrode, electrochemical series and its applications, and electrochemical cells. What is ion selective electrode? In the last class we have seen the secondary reference electrode, that is calomel electrode. Today we are going to see the ion selective electrodes. They possess the ability to respond only to a specific ions and thereby developing a potential with respect to that species only in a mixture and which ignoring the other ions completely. In other words, we can say the potential developed by an ion selective electrode depends only on the concentration of species or ions of our interest. So the glass electrode, it comes under ion selective electrode, which is universally accepted ion selective electrode for measuring the pH in the solution. And coming to the construction, it is made up of, that is a glass. In glass electrode, the glass is made up of a special glass which is of low melting point and high electrical conductivity, and we can express this glass as a Corning glass with containing Na2O, that is 22% is present, calcium oxide present in 6%, and silicon dioxide is 72%. So the assembly of glass electrode consists of thin glass bulb which is filled with 0.1 N hydrochloric acid, and a silver wire coated with the silver chloride is immersed in it. Okay, the silver chloride electrode acts as an internal reference electrode. The glass electrode is represented here. In the glass electrode, the known pH of a reference solution is determined by using two electrodes, that is a glass electrode and a reference electrode. Here we can use any reference electrode like calomel electrode or standard hydrogen electrode, and measuring the voltage generated between the two electrodes. The difference in pH between solutions inside the glass electrode and outside the thin glass membrane creates a EMF in proportion to this difference in pH. So this thin membrane is called the electrode membrane. Normally, when the temperature of the solution is 30 degrees Celsius, if the pH inside is different from that of outside by 1, it will create approximately 60 millivolt of EMF. So the liquid inside the glass electrode usually has a pH of 7. Thus, if one measures the electromotive force, that is EMF, generated at the electrode membrane, the pH of the sample can be found by the calculations. So a secondary reference electrode is necessary when measuring the EMF generated at the electrode membrane of a glass electrode. So this electrode paired with the glass electrode is called a reference electrode. The reference electrode must have stable potential. Therefore, it is provided with a pinhole or a ceramic material at the liquid junction. You see this. The reference electrode, usually we can take saturated calomel electrode. So the reference electrode always behave as a cathode. Okay. So the calomel electrode always behaves as a cathode. Okay. Yes. This is the construction and working of a glass electrode. And coming to the type of electrochemical cells, there are two types of electrochemical cells. Before explaining the types of electrochemical cells, what is electrochemical cell? I am explaining what is electrochemical cell. The devices which are used for converting chemical energy into electrical energy and electrical energy into chemical energy are known as electrochemical cells. They contain two electrodes in contact with an electrolytic solution. So there are of two types. One is galvanic cell and another one is electrolytic cell. We can call galvanic cell as voltaic cell also. A voltaic cell or a galvanic cell is an electrochemical cell in which the free energy of a chemical reaction is converted into electrical energy, That is, the electricity is produced from a spontaneous chemical reaction. What is electrolytic cell? It is an electrochemical cell in which external electrical energy is used to carry out a non-spontaneous chemical reaction. See, in galvanic cell, chemical energy is converted into electrical energy. In electrolytic cell, electrical energy is converted into chemical energy. So what are the common components in electrochemical cells? In galvanic cell as well as electrolytic cell. So we must have electrodes, electrolytes, and the salt bridge. What are electrodes? Electrodes conduct electricity between the cell and the surroundings. What is an electrolyte? It is a mixture of ions involved in reaction or carrying charge. Usually electrodes are immersed in the electrolytic solution. Okay. And what is salt bridge? It completes the circuit. It provides the charge balance. So coming to the electrodes. What are electrodes? Electrodes, there are two types of electrodes, anode and cathode, where oxidation occurs at the anode and reduction occurs at the cathode. Okay, in a cell, two electrodes will be there. One is anode, one is cathode, where anode undergoes oxidation and cathode undergoes reduction. And these anode and cathode should be dipped in the electrolytic solution. Okay, what are active electrodes? They participate in the redox reaction. That's it. And coming to the voltaic cell. So I told you what is voltaic cell. It is a device in which chemical energy is converted into electrical energy, which uses a spontaneous reaction. Example, best example of voltaic cell is Daniell cell. In Daniell cell, zinc behave as anode, copper behave as cathode. Zinc is dipped in the zinc sulfate solution and copper is dipped in the copper sulfate solution. Zinc sulfate and copper sulfate are electrolyte. So the salt bridge, which is used to connect between the two half cells. See, when zinc is dipped in the zinc sulfate solution, zinc will dissolve in the zinc sulfate solution as zinc 2 plus. It will get oxidized and the electrons will flow to the cathode, that is copper. The copper get reduced and the copper ions get deposited in the metal. This is the circuit. So here in salt bridge, sodium sulfate can act as a salt bridge. So oxidation of reaction is zinc will undergo oxidation to give zinc 2 plus and 2 electrons minus 2 electrons, and the electron will be accepted by the copper and get reduced in the reduction half cell. So overall reaction is zinc plus copper 2 plus gives zinc 2 plus plus copper. The representation of Daniell cell is shown here, and the EMF of the cell is potential of right electrode minus potential of left electrode. That is, reduction potential of right electrode is cathode and the reduction potential of left electrode is anode. So the positive value of E cell indicates the cell reaction is feasible, and the negative value of EMF of the cell indicates that the cell reaction is not feasible, and in such cases electrodes are to be reversed to bring about the chemical reaction. Electrolytic cells. So the cells which convert electrical energy into chemical energy is nothing but electrolytic cell, and the best example is electrolysis of fused NaCl and aqueous NaCl. Okay, fused NaCl means without water solid NaCl is taken, and aqueous means it is in the liquid form. So two platinum electrodes are dipped in the fused NaCl electrolyte. The two electrodes are connected to an energy source like battery. I told you the electrolytic cell means external electrical energy should be supplied to bring about the chemical changes. Okay, so the electrical energy is given by the energy source like battery. The electrode which is connected to the negative terminal of the battery is cathode, whereas the electrode which is connected to the positive terminal of battery is anode. So in case of electrolytic cells, anode is positive and the cathode is negative. But in case of electrochemical, that is a voltaic cell, cathode is positive, anode is negative. So keep this point in your mind. Then coming to the working of electrolytic cells, when electricity is passed from the battery into the cell, sodium ions start moving towards the cathode and the chloride ions towards the anode. As anode is positive, negative ions will be attracted towards anode. So the cathode sodium ion get reduced, and anode it will get the chloride ion get oxidized. So this is the schematic diagram of electrolytic cell. So though the direction of electron flow in electrolytic cells may be reversed from the direction of spontaneous electron flow in galvanic cells, the definition of both cathode and anode remain the same. Reduction takes place at the cathode, whereas oxidation takes place at the anode. When comparing a galvanic cell to its electrolytic counterpart, as is done in, occurs on the right hand half cell, because the directions of both half reactions have been reversed. So the sign but not the magnitude of the cell potential has been reversed. And this is the difference between galvanic cell and the electrolytic cell. Pause this video and go through this table for a while. Okay, let us move on to another topic called electrochemical series. So when the elements are arranged in the increasing order of the standard electrode potentials, that arrangement is called as electrochemical series. So the table is displayed here. You can pause this video, go through the table, then come to the applications of electrochemical series. So from the table, from the electrochemical series table, you can find out the ease of oxidation or reduction, where the higher the standard reduction potential, the lesser will be its reducing strength. For example, if the lithium is present at the top of the electrochemical series, it acts as a strongest reducing agent in aqueous solution. The lesser the standard reduction potential of an element, greater will be its activity. A more active metal displaces a less active one from its salt solution, and when the metals have positive oxidation potential, will displace hydrogen from acids, and the metals above hydrogen or easily get rusted, and those situated below are not easily rusted. Thank you. I hope you understand this topic. Thank you very much for watching this video.